Hi guys, welcome to another episode of Words of Ages. Today we're going to be talking about golden ratio, fractals, and the Fibonacci sequence. Basically, numerology. Today is it's going to be a long episode, and I hope you can stick with us till the end. So, have you thought about what makes us so good at recognizing patterns? And why does the spiral of a shell look so similar to the shape of a gallery in the spiral of a hurricane? Is it that our minds are seeing patterns that aren't really there and we are imagining them in a random world, or we are actually seeing signs of a deeper mathematical order in the universe? To answer this, we have to go back to the very beginning. Most scientists believe that the universe begins with the Big Bang about 138 years ago. But when we asked what caused the Big Bang, science really doesn't have an answer. Physicist Brian Greene argues that this is actually a meaningless question. He says that in most cases we know how to talk about the moment before something happens. But when it comes to the Big Bang, the sentence doesn't actually mean anything because that's the moment when time itself began. Here's an analogy. Imagine you're waking up, walking north, and if you use a compass, it's fairly easy to go in that direction. But there's one place in the world where you can't do that, the North Pole. If you're already standing exactly at the North Pole, then asking how can I go more north doesn't make sense because you're already as far as north as you can go. You can't go any further north than the North Pole itself, can you? And in much the same way, it doesn't make sense to ask what happened before the Big Bang because the Big Bang is the moment of the time began. You can't go further back in time than the beginning of time itself. Whether or not you're happy with this answer, there's another way to think about the beginning of the universe in terms of numerology. Imagine a timeline where we use the number 1 to mark the beginning, the start of something new. And on the same timeline, we think of the number 0 as the moment before the beginning. We can use this to figure out what the next moment will be like this. 0 plus 1 equals 1. If we want to see what happens after that, we continue the sequence and we add the new number to the one before it. Like this 1 plus 1 equals 2. And to find out what happens after that, we add each new number to the one before it, like this 1 plus 2 equals 3 and so on. And if we keep doing this, and we get a string of numbers that goes on forever, and it might look like a random list of numbers, but it's not random at all. It's called the Fibonacci Sequence, and it's named after the Italian mathematician Leonardo of Pisa, who later became known as Fibonacci. He introduced the sequence in Europe in the year 1202, but it's actually even older than that, and it's believed to be first discovered in India at least as early as 200 BC. But the baffling thing is this sequence shows up everywhere in nature. We see it so unexpectedly and so often that there's a whole scientific journal dedicated to studying it. It's called the Fibonacci Quarterly. One of the clearest examples of this is that we find the Fibonacci sequence in almost every kind of plant and seed. If you cut a cross section of a banana, you find that it has 3 sections. An apple has 5 flowers. Also follow the same pattern, you will have 3 petals, or 5 or 8 or 13 or 21, so on and so forth, all Fibonacci numbers. But there's another fascinating implication here. If you divide almost any Fibonacci number by the one before it, in the sequence, you get a number that looks like this, and it goes on and on. It's an infinite number. Again, this looks like a random number, but it's not. The ancient Greeks called this number 5, but maybe you've heard about it by a different name, the golden ratio. And much like the Fibonacci sequence, the golden ratio also shows up all around us in nature. Here's how we can see this. Make a rectangle with the dimensions of the golden ratio. And if you keep making a series of bigger rectangles, use Fibonacci numbers. You can draw an arc from one corner to another. Make a spiral in this shape actually reflects many of the spirals we see in nature, including storms, tornadoes, and hurricanes, all of which spin according to this pattern. And you can find this very same spiral in shells, galaxies, and even the human ear. In fact, there are countless examples of the golden ratio all over your body. Go ahead and hold out your arm and look at the section between your shoulder to your elbow, in your elbow to the tips of fingers. You will find that these dimensions follow the golden ratio, and again the section from your elbow to your wrist and your wrist to the tip of your fingers. This also follows the golden ratio and even further than that. From your wrist to your knuckles and your knuckles to the tips of your fingers again follows the same ratio. And as Leonardo da Vinci found in his famous work, The Vitruvian Man, we found the golden ratio and the dimensions of the entire body. But maybe you're still skeptical, you might say. Well, we can find patterns in some areas of nature, but what about the chaotic systems? In 1979, when mathematician Benoit Mandelbrot came up with a simple equation, he had a little idea that it would completely revolutionize science and lead to huge contributions to chaos theory and fractal geometry. But here's how the formula works. You take a number, square it. You add it to the original number, and then you continually feed it back into the equation, processing it over and over again. In using this formula, you can generate patterns that repeat it infinitely, and if you go deeper into the image, you'll find smaller copies of the original image. These patterns are called fractals. Anytime you see a figure where a small piece of it looks like the whole, that's fractal. The fascinating thing is we see fractals everywhere all around us, in the shapes of lightning balls, in the jagged coastlines of the ocean, and even in the shape of broccoli. In fact, you can even find fractals inside your own body. Your lungs are fractals, and so is your circulatory system. In a very real sense, we are all living and breathing fractals. What this suggests is that there are powerful connections between numbers in our physical world. In the deeper we go, the more it looks like there's an inherent mathematical order to the universe, which raises a profound question. Is math something we invented, or is it something we discovered? Many skeptics argue that numbers are just figments of our imagination. But even Albert Einstein wondered if math is just a creation of our minds. Then why are numbers so good at explaining the universe as we see it? Why do numbers correspond so well with the actual patterns we find in nature? And if math is something we made up, then why is it so universal and consistent? Many scientists describe this sense that numbers somehow predict what our universe will be like, even before we investigate it. And the fact that numbers are so good at this is one of the deepest mysteries of the universe. Eugene Wagner calls it the unreasonable effectiveness of mathematics, and the fact that numbers describe the universe so well is a gift that we neither understand nor deserve. All of this points to the idea that there's a hidden mathematical order that underlies all of reality in the connection between numbers in the physical universe. And this runs deeper than any of us would like to admit. We might think of this as a recent discovery, but it's actually a very old idea. We find it with Pythagoras, an ancient Greek philosopher and mathematician. We've done an entire episode on him, by the way, who lived between 570 and 1495, I guess, BC. And Pythagoras believed that numbers were the most fundamental pieces of reality. And it's only when we understand this more basic level of numbers that we can begin to really make sense of the world around us. This led Pythagoras to the idea that the universe itself and everything in it is constantly vibrating. He believed that the universe runs with mathematical harmony and precision, and in the same way that each string is a harp vibrates at its own frequency. Every planet, star and galaxy also has a unique vibration. He called this idea musica universalis, or the music of the spheres. And it was precisely this insight that led Pythagoras to say that everything is a number. Most scholars now recognize Pythagoras as the father of modern numerology as it's practiced today. He spoke these words hundreds of years before the birth of Christ, and yet even then he recognized that the universe had a kind of mathematical framework, a logical order, I'd say, that seems to reflect a deeper and hidden structure to reality. As the next 2000 years have shown, he was right. And today, with all our advances in science and technology, we seem to be uncovering the same truths Pythagoras discovered all these centuries ago. According to numerology, the power of numbers goes much further than the spirals we find in nature or the fractal patterns all around us. Using the unique numbers in your life, you can unlock insights into your personality, your relationships, and your approach to life itself. And one of the goals of this channel is to show you how. If you'd like to know more about what numbers can tell about you, your personality, your relationships, and your career, make sure to like this video and hit the subscribe button, and make sure to press the bell icon. It really does help me out, and it really does help us to bring more content like this to you, because we know you're watching. And if you've noticed the Fibonacci sequence in your life or any of these other number patterns, let me know in the comments below. A little interaction goes a long way. Thanks so much for watching, and I'd really like to see you in the next video.